Hello, good day everyone. So for our today's discussion, we have one-sided limits. And with that, our lesson objectives for today will be to determine the limit as a variable approaches a certain value from the left and or from the right. Okay, let's start with this illustrative example. Let's use the graph of h of x below, this one, to evaluate the limits and functional values. So we have h of -1. So h of -1 will be looking for a solid point since this is a functional value. So -1 is right here. So its corresponding functional value will be equal to +1. Nandito siya. Okay. What about if we have h of 0? So h of 0 sa origin yun. So ito yung corresponding y niya and that gives us -1 sa baba, no? And then for h of +3, we have this solid point again and that will be +2. Okay, so if we look for the limit of h of x, as x approaches -1 from the left, we are examining this behavior. So as x approaches -1 coming from this side, from -1 from the left, it's approaching this value. So the y it's approaching will be again equal to +1. Whereas if it's coming from the right side, -1 from the right side, will be examining, ito yung nasa right side ni -1. So we'll be examining this behavior. And as it approaches -1 from the right, it gets very near to this hollow point. So ano yung pinupuntahan niya na y value here or functional value? Lumalapit siya sa value na -2. Okay. So for number 6, we have the limit as x approaches 3 from the left. So 3 from the left side of 3, ito yung functional value. We're looking at the graph, no? So ito yung function's behavior rather. So it gets very near to this solid point. Lumalapit siya dun sa solid point na yon where the function value is approaching +2. Okay, tapos pag galing naman tayo sa right side ni 3, ito yung behavior ng graph. So lumalapit siya dito sa solid point na to and that corresponding y value for the solid point is equal to +3. Okay. So ayun, sana nakita natin kung paano minsan nagdi-differ yung limit as x approaches a certain value from the left tsaka from the right, just like this, the case of this one, and just like the case of 3. Okay. So let's now go to this example. Okay. So let's again use this graph to determine the limits and functional values, say h of -1. So sa h of -1, dito yung -1, we are looking for this solid point. We want to consider this solid point where we have equal to 2. For h of 0, dito tayo sa x-axis or sa y-axis din at the same time. So it's equal to 0. Tapos sa h of 2 naman, ito yung 2. We are considering this solid point where the h value is equal to 1. Okay. Now for the limit as x approaches -1 from the left, so -1 sa left side niya, ito yun. Lumalapit siya dito sa solid point na to, ay sa hollow point na to rather. Pag nilapitan niya tong hollow point na to, lumalapit din siya sa y value na equal sa +3. Okay? Pagka naman dun tayo sa galing sa right side ni -1, ito yung titingnan natin na behavior ng graph. So it's approaching this hollow point. Again, may hollow point tayo. And the y value na associated dito sa hollow point na to is +1. Okay? Remember yung limit, yung associated y value yung tinitingnan natin. So refer tayo sa y-axis. So for number 6, sa 2 naman from the left, 2, ito yung 2. So yung left side ng graph niya, andito tayo. So it's getting very near to this hollow point. Okay? And the associated y there is +4. Okay? Sa kabilang side naman, 2 from the right, dito tayo sa linear side ng graph. Okay? Lumalapit siya sa 2, so parang ganito yung trace nating path. So it's getting near to this hollow point where the y value associated is again 4. So as you can see, dito sa -1, from the left and right side niya, magkaiba yung limit values. Pero sa as x approaches 2 from the left and right, parehas lang na 4. Okay? So in that case, we say that the limit as x approaches 2 of the function exists. Dito does not exist. Okay? So formally, we can define our limit to be this way. If the limit of f of x as x approaches c from the left is equal to the limit of the function, the same function, as x approaches c from the right, if both are equal and equal to a real number L, then the limit of f of x as x approaches c without the superscript, whether from the left or right, exists and is equal to capital L, that same number L. Okay? So, pagka hindi equal tong dalawang to o di ka hindi equal sa isang real number, then we say the limit does not exist. Okay? So when do we apply the one-sided limits in evaluating the limit, say, of f of x as x approaches a certain number, say a naman? When the function is not defined on one side of a. Yan, so undefined siya sa isa kabilang side, no? Like for example, this case, no, where we have limit of x squared minus 4 as x approaches 2. As we know, dapat yung x natin dito, diba, if we are to determine the domain of this, dapat consider natin na dapat yung nasa loob ng radical sign must be positive, no? Bawal din siya mag-zero. So, dapat x must be greater than 2. Let's get our pen. So, dapat x must be greater than 2. Okay. Parang ito yung domain niya. So, yung 2 na nanggagaling sa left side, bawal. Okay. So, we can only find the limit as x approaches 2 from the right. Yung from the left, bawal kasi ito yung kanyang domain. Okay? So, 2 from the right lang yung makukuha natin. So, we have x squared minus 4 over square root of x minus 2. Taking a look at this function, we know that by substitution, this will be of the form 0 over 0. So, which means we can expect one factor to cancel out, and that will be x minus 2. So, we rationalize this by multiplying by square root of x minus 2. At the same time, we can factor the numerator, no? So, we have limit as x approaches 2 from the right. Okay. So, we have x plus 2, x minus 2 as factors of x squared minus 4. And then we have another radical here. Okay. Tapos sa baba, if you are to multiply this, we have x minus 2. So as expected, the x minus 2 will cancel out. But as x approaches 2 from the right, though this fraction will be approaching 1. Yan. 2 from the right, so this will be approaching, this factor will approach 0. Okay? Kasi lumalapit siya ng lumalapit sa 2, di ba? Kahit manggaling siya sa right, say 2.001 minus 2, almost 0 din yun. So, this will be this factor is approaching 0 multiplied by that positive number. 0 times a non-zero number, that will be 0 pa rin. Okay? And 0 is a real number, so the limit as x approaches 2 from the right is 0, although the limit as x approaches 2 from the left of the same function, x squared minus 4 over square root of x minus 2, this will not exist. Yan. Okay, so does not exist. Our acronym for that is DNE. Okay, now let's go to our second condition. When the function's behavior is different on each side of A. Yan, merong magkaiba yung behavior niya sa left tsaka sa right, no? Like for example, this one, di ganun ka-obvious, pero this is what we call the greatest integer function. This is actually the greatest integer function. Or in short, GIF, no? Greatest integer function, ano nga ba ito? Let us recall. Yan, this is a special type of function where we round any number down to the nearest integer. Okay, nearest integer. Okay. So, nearest integer pero dapat less than or equal sa kanya. So, ang symbol niya is like this. Parang meron kang bracket tapos meron kang absolute value sa loob. Okay? So, yun. Meron kang bracket tapos may parang absolute value ka pa sa loob. Okay? So, this is the greatest integer function of x, similar to our example here. Okay? So, pag sinabi natin kunwari greatest integer function of 5, Pagka integer na yung nasa loob, equal yun sa 5. Pero when we say greatest integer of 5.2, this will be equal pa rin sa 5 kasi 5 is the greatest integer less than or equal to 5, no? If we have 5.9 or 5.99, yan. The value of this is still 5. Dapat ng mga nagiging answer natin is 5. So, bali lumalabas from 5 up to 5.99999 dito sa banda dito, ang value ng function natin is 5. So, constant siya all throughout unless maging almost equal kay 6. Okay. Kaya dito mapapansin natin, for example, let's take this random half open line segment here, half open line segment. Kasi yung isa ay solid point, yung kabila ay hollow point, may butas, no? Kasi starting with 3.0, yung saktong 3, up to 3.99999, ang value ng function mo, ng greatest integer function is 3. Okay? Yan, so lumalabas. Pag negative, medyo nakakalito, no? Pag negative 1, the greatest integer function is negative 1. Pero kapag kunwari negative 1.01, negative 1.01, nandito na siya located, di ba, sa kabilang side. No? Kaya ang magiging greatest integer nito ay negative 2. Okay? So unlike sa mga positive integers, no, idadrop mo lang kahit sa 0, idadrop mo lang yung kanyang decimal part, you have the greatest integer function value already. Pero kapag negative yung integer, okay lang kapag ka-integer yung nasa loob, you just copy that. Okay? Kasi ang mga values mo, ang magiging answer natin dapat laging integer. That's why it's the greatest integer function. Pero kapag negative 1 point something or negative integer point something, dinadrop natin yung decimal part tapos nag-a-add tayo ng negative 1. Okay? So if we have, for example, negative 13 point, say 99, yan, idadrop natin tong decimal part tapos negative 13 minus 1, negative 14. Same as if we have negative 13.001. This will still be negative 14. Drop mo yung decimal part, then add negative 1. Kasi pupunta na siya sa kasunod. Eh. Remember, if we are to take a look at that using the real number line, dito natin lagay. Kunwari, andito tayo sa, kunwari ito yung 0, tapos nandito yung negative 13, dito yung negative 12. Let's forget about the 0 na lang there. Negative 12, tapos negative 14. Eh, yung negative 13.01 is already located here. Okay, so dapat yung greatest integer na nasa less than or equal niya. So, ito yung negative 14 yung nagiging answer natin. Okay? Ayun, parang technically on the real number line, it's the greatest integer kapag decimal yung given sa loob. Okay? It's the greatest integer na nasa left niya. Okay? Yun. So, tingnan po natin ito. No? Pag tiningnan natin yung ating limit as x approaches a from 8 from the left of this function. Tapos we have limit as x approaches 8 from the right of the same function. Pag 8 from the left, we can get 7.9, 7.99, 7.99999, and the greatest integer function of those numbers will be 7. Diba? Kahit lumalapit siya sa 8, pero hindi naman siya kasi dapat mag-i-equal dito sa number mismo na to eh. Diba? Lumalapit lang siya ng malapit na malapit. Si 7. Say 1,000 na 9. No? 7.9999999. 7 pa rin ang magiging greatest integer function ng number na yon. Okay? Whereas here, if we are approaching 8 from the right, yan, if we're approaching 8 from the right, what we have will be 8.1, 8.001, lapit pa, 8.0000001, di ba? Yung mga greatest integer function nun, wala tayong problema, equal pa rin yun sa 8. Diba? If we illustrate that using the real number line, eto si 8. Tapos manggagaling tayo sa left, meron tayong 7, meron tayong 9. So dito tayo, no, pag ganun, kung manggagaling tayo sa left. So meron tayong value dito 7.9, 7.99, 7.999, di ba? Still, 7 pa rin yung GIF niya. Okay? Pero pag dito, pag ganun yung behavior natin, so we're taking a look at the values here. Yung 9 malayo pa, kahit yung 8.9 ba, malayo pa yun. No? So dapat palapit. No? So 8.1, 8.01, 8.00001, 8 yung kanyang magiging GIF. Okay, so as we can see here, these are not equal. So the limit without the quote-unquote superscript as x approaches 8 of the greatest integer function does not exist. Okay, kasi di ba sabi sa ating definition, the limit from each side should be equal and both should be equal to a real number. Okay. Now, let's take a look at the third condition. When f of a is equal to c of 0, ano yung f of a na to? That is the value of the function when we substitute the value here to the variable. Okay? Kapag ang nakuha natin is undefined, this is undefined, yung non-zero number over 0, that is undefined, no? Yan. So, ibig sabihin, magko-consider din tayo ng one-sided limits. Like for example, this one, no? 3 minus 3 is 0. Tapos denominator natin is 9 minus 18 plus 9, that is 0. So you might be thinking, hindi naman ganitong form, so indeterminate. So you will have a tendency to factor kasi di ba yung 0 over 0, you have two options, di ba? Pag 0 over 0, you have factoring as an option or you rationalize. Okay? So, you have limit, di ba? Magpa-factor tayo as x approaches 3, where the expected factor to cancel out is x minus 3. No? So, we have x minus 3 there. Expect that to cancel out. Pero our denominator is x minus 3 times another x minus 3. So, only one of the x minus 3s will cancel out. Yung one pair. So, we're left with 1 over x minus 3. So, na-trap na tayo dito sa limit of 1 over x minus 3 as x approaches 3. Okay? So, if this is the case, kukunin natin yung limit from the left tsaka from the right daw kasi we have a non-zero number over 0 once we substitute this, no? This 3 here. Okay? Magiging siyang 3 minus 3, 0 to. Okay? So, 1 over 0 is of this form. Okay? So, we have 1 over x minus 3 as x approaches 3 from the left and as x approaches 3 from the right. Okay. So, as x approaches 3 from the left, we will have 2.9, 2.999, diba? And then 2.999, we will be getting a decimal number here. So, makukuha natin, diba? Let's make a table of value for x and 1 over x minus 3. Say 2.9, galing tayo sa left, 2.99, 2.999. If we have this, that will be negative 0.1. 1 over negative 0.1 is what? 1 over negative 0.1 is 1 over 1/10. Negative 1/10. So this will be negative 10. You can verify that this will be negative 100. This will be negative 1,000. And as you increase the number of nines here, getting closer to 3, this will be approaching a very large number. No? Magdadami pa yung zeros niyan. Maging 1 million, 1 billion, 1 trillion, etc. So it's safe to say that it is approaching negative infinity. Okay? So the answer here will be negative infinity. Hindi na siya real number, so hindi na siya mag-i-exist. The limit does not exist, yung without the quote-unquote superscript. Kung galing naman tayo sa right side, tingnan natin ano kaya ang magiging answer natin dito. Kunwari curious tayo, no? 1 over x minus 3. Papalapit sa right, di ba? Ito yung 3. Ito yung nasa left niya, 2. That's why we get 2.9, 2.99. Yun yung inobtain natin. Pero kung galing tayo sa right, we have 3.1, 3.01, etc. Say 3.1, lapit pa tayo. Lapit pa tayo. Okay? 3.1 minus 3 is 0.1 or 1/10. So 1 over 1/10 is 10. can verify that this will be 100, this will be 1,000. So again, as you increase the number of zeros here, diba, as we get very close to positive 3, it's safe to say that this will be approaching positive infinity. Magiging itong 1 million, 1 billion, 1 trillion, diba, 1 decillion, etc. Okay, so we say the limit of 1 over x minus 3 as x approaches 3 from the right is positive infinity. We will go back to this part as we discuss the infinite limits. Okay. So ayun po, negative infinity and positive infinity. Yan. You can actually check on this para mas madaling makuha kung negative infinity na marirealize natin pag nasa form na siya na c over 0, yan, pag dumating na siya sa puntong ganito, ang answers na na-obtain na lang natin will be positive infinity or negative infinity. Nalilimit na lang dito sa dalawa once we have this, just like this one for our limit. Okay. Now, let's go to condition number 4, which is my favorite. When f of x is a piecewise function, the given function here is piecewise, and a is a transition point. Okay? Just like the f of x here, tapos the 1 here is a transition point. Okay? What do we mean by transition point? Parang lumalabas siya yung, parang kumbaga sa LRT stations, para siyang isang terminal. No? Sa left side niya, our function is defined as x squared plus 2. Pero paglampas mo sa kanya, our function is defined as 3x minus 1. Okay? So from here, yan, papa left side, ito yung definition ng function. Pero starting with 1.01, 1.1, ito naman yung definition ng function natin. 3x minus 1. Okay? So if we are to get the limit of f of x as x approaches 1, we need to get the limit from each side. So kunin natin yung limit as x approaches 1 from the left of the function f of x. Tapos, ang pipiliin natin kung nanggagaling tayo sa left side, di ba? Dito tayo lumalapit. Ito yung behavior ng function natin. We will be considering 0.9, 0.99, 0.999. We'll be using the x squared plus 2 as the definition of the function. F of x is equal to that. No? So, we replace f of x here by x squared plus 2. So, we have limit of x squared plus 2 as x approaches 1 from the left. Okay? So, 1 from the left, so 0.9, 0.999. Pero it's safe to say that our function, x squared plus 2, is approaching the value 1 plus 2, which is equal to 3. Yan. Parang pwede natin sabihin na once we have chosen which part of the piecewise function to use, yan, we can practically more or less ignore the quote-unquote superscript of the value x is approaching. Okay? Whereas dito naman sa kabila, limit of the function as x approaches 1 from the right. No? So we can replace sa 1 from the right, dito tayo manggagaling pag ganun yung behavior natin. So we consider the values here. And the function f of x is equal to 3x minus 1 for all the values greater than 1. Greater than 1 to, right? So that means we replace the f of x here by 3x minus 1. So andun pa rin yung limit notation of 3x minus 1 as x approaches 1, okay, from the right. And it's practical to just substitute the 1 here. 3 times 1 is 3, minus 1 is equal to 2. Okay, so since these two values are not equal, we say the limit of f of x as x approaches 1 without the direction or superscript, quote-unquote, does not exist. Okay. Yan. So, tingnan natin yung mga examples. Beginning with example 1. We have limit of x plus 3 over x minus 3 as x approaches 3. Let's get the limit as x approaches 3 from the left. Yan. By substitution, this will be of the form 6 over 0. So, 6 over 0. It's of the form constant over 0. So we know the answer for the limit on each side will be either positive or negative infinity. Okay? So ang technique, let's use our shortcut. This will be 6. This will be 0. Pero since we're coming from the left, we'll be getting, say, 2.9. Let's illustrate that here. Kahit yung 3, lalagay natin sa gitna, and then we have the 2 and the 4 on each side. So kung manggagaling tayo sa left side, we have 2.9. 2.9 representative point or 2.99 minus 3. That will be negative. So that means before this becomes 0, it actually comes from negative values. Okay? Coming from negative 0.1, negative 0.001, negative something. Okay? So it's a matter of determining the sign. So positive over negative is negative. So we choose the negative sign for our infinity. Okay, that will be our shortcut. Some sort of shortcut. So ito naman, meron tayo ditong, again, numerator is 6. Denominator is, again, 0 by substitution. Pero if we're coming from the right side of 3, we're considering these values, 3.1, 3.01, and we're getting positive answer. Positive yung difference kasi the mean when is greater than the subtrahend. So positive over positive, that means we have positive sign for our infinity. Okay? So nonetheless, ito ay does not exist na. Yan. Pero getting the behavior of the function as x approaches 3 on each side, ito yung makukuha natin. Okay? Parang lumalabas, if we have a 3 here, graphically speaking, ito tayo, yan, ito yung x equals 3. As x approaches 3 from the left, papunta tayong negative infinity. Pababa. Yan, parang asymptotic siya doon. Okay? Tapos as x approaches 3 from the right, papunta naman siya sa taas. Tataas siya. Yan. So asymptotic pa rin dun sa x equals 3. Actually, with that one, we say x equals 3 is a vertical, the line x equals 3 is a vertical asymptote. Yan, parang commercial break. Now let's go to our example 2 where we have the limit of x squared plus 3x minus 10 over x squared plus 10x plus 25 as x approaches negative 5. So ayun, factorable ba to? Medyo, no? This is factorable as well as the denominator, okay? So if we take a look at the factors, we have limit x plus 5 kasi of the form 0 over 0. Tapos negative 10 divided by positive 5 is negative 2. So sa baba naman, if we factor this, that is a perfect trinomial square. So we have x plus 5 times another x plus 5. Okay. So magka-cancel yung isang pair ng x plus 5. We're left with x minus 2. Negative 5 minus 2 is negative 7. Correct? Tapos negative 5 plus 5, denominator is 0. Okay? Again, nasa form siya na constant over 0. So it's a matter of determining na lang whether it's a positive infinity or negative infinity. So before this actually becomes 0, so we don't accept this as our value for the limit. Okay? Hindi tayo nag-a-answer ng undefined or indeterminate sa ating limit. No? So ini-examine natin yung sign. As in, yung sign ng numerator tsaka denominator. This is negative. Pero yung denominator natin, before it becomes 0, saan siya nanggaling? Okay? Let's examine ha. So, negative 5, lagay natin sa gitna. We have a negative 6 and negative 4 here. We have negative 5.01, correct? So, negative 5.01 plus 5, that will be negative. Mas lamang yung negative, no? So, before it actually becomes 0, galing siya sa mga negative values. Negative divide by negative, that will be positive infinity. So, that means the limit from the left is positive infinity. Like signs, no? Positive infinity. And more or less, we can predict since magparehas lang naman po yan, we'll arrive at the same x minus 2 over x plus 5. Yan. As x approaches negative 5 from the right this time, di ba? Magiging kinonsider na natin nag-cancel yung x plus 5. Okay? Parang dinivide na natin both of this by x plus 5. So, ang answer natin, negative 7 over 0. This is negative, pero kagaling ka sa right, meron ka ditong negative 4.9, negative 4.99. So, negative 4.9 plus 5, that will be positive. So, negative over positive, this will be negative infinity. Okay. So again, ang ibig sabihin ng superscript natin is the direction where we're coming from. Hindi yun minumultiply kasi some students will do negative 5, negative, ika-cancel, magiging positive 5. That's a no-no. Okay. So the answer for the limit values or limit behavior is negative infinity for this and positive infinity kapag sa left side. Okay. So, ayun. Kasi pag limit, we're actually examining the behavior of the function. Okay? What about in here? What is the limit of this function as x approaches negative 5? So, negative 5 plus 5, 0. Negative 15 plus 15, 0 din. Pero as we know, dapat ito ay positive or at least equal to 0 since nasa numerator siya. So for the domain of this function, our x must be greater than or equal to negative 5. Diba? Kasi pag negative 6 na siya, bawal na, no? So dapat nandun siya sa negative 5. Pag ganun. Included yung negative 5. Okay? So ang meron tayo ay yung from the left lang, no? So yung from the right side lang. So ito ay does not exist na automatically. Hindi na natin mahanap yung value niya. Define yan. Okay? What about from the right? No? So 0 over 0. So that means may magka-cancel, may factorable, may mara-rationalize. So we multiply by square root of x plus 5 over square root of x plus 5. We're rationalizing sort of kasi gusto natin malabas sa radical yung numerator natin. Okay? So we have the limit. Tinawag ko lang na sort of rationalizing, although this is not rationalizing per se, no? Kasi wala naman sa denominator yung radical. Okay? Pero it's important that we see the magiging x plus 5 siya. That is the expected factor to cancel out. Tapos sa denominator, we factor this. That will be 3 times x plus 5. Pero meron ka pang square root of x plus 5. Okay? So although this will cancel out, yan, this fraction approaches 1. Yan. So 1 na lang yung numerator. Tapos sa baba meron kang 3. Square root of x plus 5. So kung nanggagaling ka sa right side ni negative 5, dito ka, dun sa number line, referring to your number line, you have negative 4.9, negative 4.99. You have something that approaches 0 here. So nag-a-approach sa 0, okay? So magiging ano din siya, 1 over 0, okay? So ang tendency, hanapin mo na lang yung sign niya. This is positive, numerator is positive. Tapos we're coming from positive values pa rin dun sa denominator. Kasi ang answer natin dito, it's either positive or negative infinity. Kasi mag-a-approach pa rin to sa 0 di ba? So, ang magiging answer natin, positive over positive. We have a positive factor there, di ba? So, it will be positive infinity. Okay. Now, let's take a look at our next example. We have this piecewise function. So, if we are to find the limit as x approaches negative 1, negative 1 here is a transition point. So, let's take a look at that. You have negative 1 here. Sa left side niya, we have the absolute value of 2x plus 1. Tapos, starting from the right side, yan, dito naman, our function is defined as 2x squared minus 3. Okay? So, dito, 2x plus 1. So, kung nanggagaling tayo sa left, ayun na pala. Ayan. Kung nanggagaling ka sa left, you'll be using this behavior. Ayan, papunta tayo doon. Okay? So, gamit tayo ng absolute value of 2x plus 1 to replace our f of x, this one. Okay? So, we have limit of absolute value of 2x plus 1 as x approaches negative 1 from the left. This will be negative 2 plus 1. Negative 2 plus 1 is negative 1, pero getting the absolute value, that will be positive 1. So right side naman, we will be considering this behavior of our graph, okay? Or of our x, no? So ito yung gagamitin nating definition ng ating function. Okay, those values of x here are greater than negative 1. Okay? So 2x squared, it's a matter of replacing, sorry about that. Replace natin si f of x by 2x squared minus 3. As x approaches negative 1, this will be approaching 2 minus 3, and that will be negative 1. Okay. So negative 1 to, this is positive 1. So the limit as x approaches negative 1 without the direction does not exist since these two are not equal. Pero yung limit from each side, meron tayong nakukuhang value. The limit from each side exists kasi meron kang numerical value. So for example 5, we have this piecewise function. Meron tayong limit of g of x as x approaches 0. Meron tayong 0 tapos 3. Dito tayo sa 3x minus 1. Tapos sa gitna, meron tayong x squared plus 2. Yan, considering these definitions of our function. And sa right side ni 3, we have 5x minus 4. So as x approaches 0 from the left, dito tayo sa behavior na to, we replace our g of x by 3x minus 1. So we have limit of 3x minus 1. As x approaches 0, kahit from the left, it's safe to say that it will be 0 minus 1. It approaches negative 1. It will get very near to that value. Okay? As x approaches 0 from the right naman, pag ganito yung behavior niya. Okay? So, 0 from the right, ito yung gagamitin nating definition ng g of x. So, we will have limit of x squared plus 2 as x approaches 0 from the right. So, we have here 0 plus 2. So, this is approaching the value 2. So, ito, negative 1, ito ay 2. So, the limit of g of x as x approaches 0 does not exist. Okay. Okay, so for our next example, we have if g of x is equal to 3x minus 1. So, same function. This time we have the limit of g of x as x approaches 3. So, if we are to get the limit as x approaches 3 from the left, we're going to consider this behavior of x. No? So, x is approaching 3 pero from the left. So, we are after this. No? Ito yung gusto natin. Ay, sorry for that. Okay. So, this time we're going to use this function. Okay, so we're going to replace our g of x by x squared plus 2. So this will become limit of x squared plus 2. Yan. So g of x is equal to that for that interval. So x approaches 3 from the left. So we will have 3 from the left. Nandun yung 2.9, 2.999. So it's safe to say that as x approaches 3 from the left, this value will approach, this will get very near to 9 plus 2. So this will be equal to 11. Okay. Now if we have the limit as x approaches 3 from the right of the same function, we have this behavior of our x. So we're going to consider this for our value of the function. So we're going to have limit of 5x minus 4 as x approaches 3 from the right. Okay, so we're going to consider 3.1, 3.01, 3.001. It's safe to say that this value will be approaching 15 minus 4, so that's equal to 11. Okay, so these are equal. Yay! So that means the limit exists and is equal to 11. Okie dokie. Now for our example 7, let's have this one. We have limit of 8 minus 2x all over absolute value of x minus 4 as x approaches 4. Okay, so if we're going to substitute 4 to our function, this will become 8 minus 8, 0 over 0. So nasa form na 0 over 0, kaya tendency we can factor or cancel. But then, this is an absolute value function. So remember, an absolute value function is actually a piecewise function. So if we recall, di ba, yung absolute value of x is equal to x if x is greater than or equal to 0. It's equal to negative x if that number inside is less than 0. So that means yung absolute value of x minus 4, this is equal to the number itself, yung number na x minus 4, if x minus 4 is already positive or 0. Yan. So, kapag hindi naman, kapag negative itong nasa loob, we take the negative of that if x minus 4 is less than 0. Now, how do we spell this out? Yung x minus 4 less than 0. Solving for that inequality, we can move this to the other side. So that means x is less than 4. So yung kabaliktaran niya, x greater than or equal to 4. So meaning 4 is a transition point. This is actually a piecewise function where 4 is a transition point. So for the left side, we have negative of x minus 4. We're talking about the absolute value. Tapos sa right side ng 4, the absolute value is equal to just x minus 4. Okay? So ibig sabihin, kukunin natin yung limit from each side. So as x approaches 4 from the left, we have 8 minus 2x. Notice that this is factorable. We can factor out the 2. So this becomes 4 minus x. Tapos sa baba, negative of x minus 4. Negative of x minus 4 is actually negative x plus 4 or 4 minus x. Ayan. So that means this will cancel out. So this is equal to 2. Ayun. What about if we have limit as x approaches 4 from the right of the same function? So yung 8 minus 2x na factor natin, ano? Kasi nasa form siya na 0 over 0. That's why we did some factoring. So factors are 2 times 4 minus x. Pero yung piecewise function will be replaced by this kasi we're considering values of 4, values of x that are greater than 4. So we have x minus 4 here. Now if we divide this and this one, the fraction becomes negative 1 or approaches negative 1 as x approaches 4 from the right. Okay, so we have 2 times negative 1. Therefore, this is negative 2. Yan. So, makikita natin these are not equal. So, the limit as x approaches 4 of this original function does not exist. Okay. Now, for our example 8, we have a piecewise function. Okay? Ang titingnan muna natin, does this make this one an integer? Itong nasa loob ng ating greatest integer function notation. Okay? So, 2 times 1 half plus 1, this is 1, plus 1, so that is equal to 2. So, that means yung 1 half is actually parang sort of transition point, meaning magkaiba yung value ng greatest integer function sa left and right ng 1 half. Okay? So, lagay natin yung 1 half sa gitna. Meron tayong 0 sa gilid, tapos meron tayong 1. No? We can consider those. No? Although pwede nating mas maggawin pang kunwari, this is 1/4, this is 3/4. Okay? Kaya lang ginawa na lang natin convenient. So, we chose integers for its neighboring points. Okay? Anyway, so this is actually 0.5 in decimal form. We can consider here 0.49, 0.499, no? So if we consider those values and substitute them here, 0.49, magkaiba yung magiging value natin versus yung nandito na 0.51, 0.5001, di ba? So we have to get the limit as x approaches 1 half from the left, tsaka 1 half from the right. Okay, so we have the greatest integer function of 2x plus 1. Sa baba, wala tayong problema, 3x. Greatest integer function of 2x plus 1 tapos 3x. Same function. Okay? So, try natin, no? This is point, kunwari, we get a representative point, no? 0.49, 0.499. This approaches siguro 0.98, no? Times 2, no? Plus 1, that will be 1.98. And the greatest integer function of that is 1. Okay? Parang pwede nating isipin na kung 1/2 ito, kapag 1/2 yung x, di ba? That will become 2 times 1/2 is 1 plus 1, kaya 2. Since this is an increasing function, yung kino-consider natin na x nasa kaliwa ni 1/2. So, pwede nating isipin na kukunin natin yung integer 1 lower than 2. So, it's 1. Okay? Kasi increasing function to. Nasa kaliwa ka, pababa. Okay? So, 3 times 1/2 is 3/2. So, this is actually just 2/3. Okay? So, dito naman, consider natin yung 1/2, no, na nasa positive side. So, ayun naman, 2 times 1/2, 2 times 0.5001 will be 1 point something, plus 1, that will be 2 point something, and the greatest integer of that is 2. Plus 3 times 1/2 is 3/2. Yan, that approaches 3/2. So, 2 times 3/2 will just be 4/3. So, ayun, you have two different values for the limit of each side. So, yung limit ng x approaches 1/2 does not exist. Pero yung individual limits natin, yun yung nag-i-exist, just like in the previous example. Okay, you can always pause the video if you want to absorb our lesson. If you want, pwede din po tayo mag-explain pa ng greatest integer function on the other videos that I will be uploading. Okay. So, let's have our summary. Ito, so far, meron tayong limit of f of x as x approaches a. Our first procedure is to substitute a, this value, to our variable x. Yan, so pwedeng mag-iba yung variable, pero basta gano'n, no, sinag-substitute natin yung value na nandito dun sa variable. Tapos, if we get a real number, we stop. If we get 0 over 0, which is indeterminate, our two options will be to factor or to rationalize. Okay, yan yung oo, kasi magpa-factor ka or magra-rationalize. Pero kapag ang nakuha natin upon substitution is constant over 0, and meaning yung constant is non-zero over 0, ang tendency, ang makukuha nating sagot is either positive infinity or negative infinity, depending on the sign of this constant and depending on the sign sign of the denominator before it becomes actually 0. Okay? So, consider mo na yung direction kung saan ka nanggagaling na value ng variable. Okay? So, ayun po. Tapos, syempre, consider natin yung mga conditions where we need to apply the piecewise function. Tapos, meron tayong transition point. Tapos, kung nasa left and right tayo, etc. Okay, so let's get ready for time for questions. We have number 1. What is the limit of 9x squared minus 3x plus 10 all over 6x minus 4 as x approaches 2/3 from the right? Okay, fast forwarding our timer. So in medyo ano po natin, no, naka-specify po yung ating direction. Okay? So we have 6x minus 4 here. If we substitute 2/3 to our fraction, yan, or rational expression, that will become 0 over 0. This will be 9 times 4, 9. So it's 4 minus 2. Sorry, hindi pala, no? 4 minus 9 times 2/3, 9 times 4, 9s. Minus 3 times 2/3 plus 10. Okay, so this will be 4 minus 2. 2 plus 10 is 12. Tapos sa baba natin, that is 6 times 2/3 minus 4. This is 4 minus 4, so yun yung 0. So this one is positive, while this one, before it actually becomes positive, ano yung sign niya? So doon na natin i-consider yung nasa right ng 2/3, no? So nasa right ng 2/3, this pwedeng isipin natin 1 kagad or 3/3. Pero medyo palakihin natin siya, multiply natin siya ng say 5/5. So this will make it 10/15. Okay? 10/15. So kung nasa right, let's choose 11/15 kasi para mas malaki yung mas maliit yung difference, no? Kung pwede nga lang 100/100, no? Anyway, so 11/15 is convenient enough. So 6 times 11/15, our representative point, minus 4. What will be the sign of this? Dividing this by 3, this is 2, this is 5. So 22/5, this is 20/5. So 22/5 minus 20/5 is positive. So therefore, the answer is, sabi natin, pag constant over 0, the answer is just positive or negative infinity, pero we choose the positive infinity, like signs. Okay, now let's go to number 2. Find the limit as x approaches -3 from the left of the greatest integer function of 5x minus 3. Okay, I will fast forward our timer again. So, as we know, -3, pag sinubstitute natin sa x, that will be 5 times -3. That's -15, no? Minus 3, that's -18. Kaya lang, but that's not how it's supposed to be, no? Since increasing yung function, tapos nasa left side ka ng -3, you should be getting the integer that is 1 unit less than this. So -18 minus 1, the answer is -19. Okay, so if you're not yet convinced with that, pwede ka mag-plot, no? You have -3 here, that's -2 and -4. Kung galing ka sa left, pwede mong i-consider si -3.1, -3.01. So -3.01, multiply it by 5, then minus 3. This is -15.01, 0.05. That will be -15.05 minus 3. That will be -18.05, no? Okay, so anong greatest integer function ito? What is the GIF of that? It will be, diba, -19. Kasi if you look at that, the -18.05, nasan siya? -18.05 is right here. So, -19 yung kanyang greatest integer function. Sabi nga natin ang shortcut pag negative decimal, we drop the decimal part tapos add -1 on the remaining integral part. Okay, let's have number 3. What is the limit of this as x approaches -6 from the left? Okay, I will fast forward our timer again. Okay, so meron tayong x plus 6, which is actually a piecewise function. So let's have this, x plus 6. This is equal to x plus 6. If x plus 6 is already positive or x is greater than or equal to -6. Otherwise, kapag yung x natin is less than -6, we will use the negative version of this, which is -x minus 6 or negative of x plus 6. Okay, so is this of the form 0/0? We'll check, no? So -6 squared is 36 plus 12 times -6 is -72. Okay. Tapos plus 20. Plus 20. So that's 56. 56 minus 72. Ayan, hindi siya 0/0, no? So 36 minus 72 is 36 plus 20 is 56. 56, we subtract 72. So, kuha. Ano natin, no? 56 minus 72 equals negative 16. Tapos kung galing tayo sa left side ni negative 6, nandito tayo sa less than part, we will choose the negative of x minus 6. So negative x minus 6 to replace this portion, minus 4. So we have limit as x approaches negative 6 from the left. Di pa tayo nag-evaluate kasi may variable pa, no? So nandun pa yung notation natin. Sa numerator, okay na tayo. So sa denominator na lang, okay? Kasi limit naman of a quotient is equal to the limit of the numerator over the limit of the denominator, provided the limit of the denominator is non-zero, di ba? From our properties of limits. So if you substitute negative 6 to our x, negative of negative 6 is positive 6, minus 6, that will be 0, minus 4, that's negative 4. So we have 16 over negative 4. Okay. Diba? Tapos, magigilang siyang positive 4. So, positive 4 is our answer. Okie dokie. Now, let's have number 4. This is a piecewise function, and we're supposed to get the limit as x approaches 1 from the right. Okay, I will fast forward our timer again. So, from the right, so that means we'll be using the x minus 1 for our f of x, this portion. Okay? Kasi nasa greater than side tayo because of this part. Okay? So we will replace the f of x by x minus 1. We'll have limit of x minus 1 as x approaches 1 from the right. Yan. So technically, pwede na tayong mag-substitute lang ng 1. This function will approach the value 1 minus 1, and that is equal to 0. Okay, let's have number 5. Based on the graph, what is the limit of f of x as x approaches 1 from the right? Okay, fast forwarding our timer. I suppose this one will be very easy. So 1, nasa right side tayo ng 1. So gusto natin malapit, no? This one is a bit far pa. So we want to consider this behavior of our graph, okay? So pag ganun, this, if trace natin yung path, it's leading towards that hollow point, okay? And the y value corresponding to that hollow point is 3. So that means the limit function is 3. So there you go. I hope you got 5 out of 5 in this set of exercises. And to end our presentation, happiness and sorrow are two sides of the same coin called life. Whatever befalls you, walk on unattached. Good day and God bless everyone.